Thanks everyone for being here. My name is Castellana. I'm the co-founder and CEO at GenLayer. I've been in this industry for about 13 years, more or less, on different L1s, different DeFi protocols. And about 3 years ago, I started looking into LLMs. I started to build a bunch of agentic frameworks, and also got into some pretty heavy litigation, right? So what I'm going to be talking about today is a bit of a different thing than what you guys are used to, right? We've been in this industry for a while, right? We have a lot of solutions on how to make agents be transacting with other agents, right? We've been working for over a decade to make sure that everything is cheap, everything is safe. We have a lot of different solutions for that, right? And I want to propose a question that I think that many of you haven't heard before, and like, why are we not hearing that before? And actually, that's basically our solution to this question, right? The thing here is, we live in an amazing moment. There's basically, we've been able to turn sand into thought. That's Mark Andreessen saying this, right? I think it's absolutely unbelievable what's happening right now. What's going to happen as well is that all these agents, as my colleagues just explained before, are going to be taking over, are going to start to be transacting with each other, and that's all very nice, right? It's going to be accelerating a lot of things. But I think we need to remember these guys are pretty smart, right? So they're going to be starting to save on costs, cutting corners, lying, cheating. And so the question is, if two agents disagree, how do they trust each other? How do they have a judge? Do they have a decision maker? How do we make it so that we can have actual real contracts that can be agreed among two different parties without having to rely on the typical mechanisms that we've been using so far, right? Because the problem right now is that the legal system is already broken. There's like 5 billion people in the world that don't have access to that. It's very expensive, very slow, it's quite biased, it's very much uncomfortable if you have ever been in that situation, right? So do we think that they're going to be using lawyers? How will that work? That's a problem, right? Maybe smart contracts can fix this, right? That's why we guys are here, right? We all think that blockchain, have these smart contracts, they're 24/7, self-enforcing, very cheap. That's very nice. The problem of that is that smart contracts are quite limited in what they can do, right? What you see is that smart contracts, if you try to create one smart contract that is trying to understand, is this thing that has been delivered professional quality? Probably will not be able to do that, right? If you say, has this thing, that has been delivered, for example, is it legal or not? This ambiguity that normally you have in any type of real world contract, it's something that smart contracts cannot do at all. So the problem here is that Ethereum and all other blockchains require a deterministic setup. Every validator needs to see exactly the same thing. That's why you have that, all verification in crypto pretty much goes from comparing hashes, right? And that basically means that anything that is non-deterministic, well, that kind of falls through the cracks, right? Like we're trying to see that, everything is deterministic, meaning that given an input and an output, the same input will give you always the same output. But the problem is that these AIs are not like that. These AIs are probabilistic, they're stochastic. They give you different responses every time that you ask them, right? And also, if you start to think about the type of contracts that they will need to be engaging on, many of those contracts are actually quite, as I said before, ambiguous, right? Is, say, for example, something like high quality. Can it be that the one that is servicing something thinks that what it delivered is high quality and that the customer thinks is not high quality? Happens all the time in the real world, right? How can we imagine a world in the future with all these billions of agents if they cannot have a dispute resolution system that essentially works at this type of machine speed? Because in reality, most of the contracts in the planet work like that, are ambiguous, are not clear, right? And so the thing here is, again, if they disagree, who decides, right? Are we going to go to the legal system is expensive? Are we going to go to smart contracts? They have some limitations. Are we going to just, trust them? Are we going to have just a reputation system? That's something that's actually happening quite a lot, right? Are we going to go back to just trusting in, counterparties, platforms, right? I mean, I think that if you guys are here, for the most part, you would like to see that, that we have decentralization to some degree, right? And the problem here is that this is not getting fixed. It's actually getting worse because we're just trying to, pretty much what you see is like most of the things that are working right now are kind of like leaning towards centralization. Why? Because the primitives that you can do in crypto, if you're just playing with deterministic tools, are quite limited. So The question here is, we live in this AI age, right? Execution is cheap, writing code is cheap, everything is cheap. What is expensive? What's the bottleneck? The bottleneck is actually making decisions, is a judge. Is actually how do you have a judgment, right? How do you have common sense? How do you trust without having to trust a single entity? And to my knowledge, basically nobody's working on this except for us. So what we're proposing today is this new type of consensus, essentially a consensus over interpretation, right? This, what GenLayer is a trustless decision-making protocol. You can think about it like a digital judge, right? You have Bitcoin giving you trustless money, Ethereum giving you trustless applications, GenLayer gives you trustless decision-making. Again, a digital judge in a sort of synthetic jurisdiction that works 24/7, self-enforcing, like a smart contract, but also can understand natural language. Also can go to the internet, fetch some information, and make a nuanced decision, right? And so let me tell you a bit how it works. It's not too, I'm not going to go super deep. But basically, the stack works like this. There's this GenLayer chain. That's like the banking system. And on top of this GenLayer chain, there's this consensus algorithm. I will talk about it in the next slide, where basically, all the different validators in the network, that's up to 1,000 validators, are going to be selected at random to do something. I'm going to talk about this in just a second, right? Each one of these validators, this is a permissionless network. You all can join whenever you want. I mean, it's not live yet, but very soon, right? You can join the testnet if you want. All of these validators are going to be running this thing called the GenVM, which is an execution environment that can do these non-deterministic operations, right? So what I'm proposing here is essentially a new type of DLT that is capable of non-deterministic operations, something that basically everybody else can't do that because they're trying to do something in a deterministic fashion, right? We'll see some use cases in just a second. You will, I think, understand it more. But essentially what's happening is that the GenVM, this execution environment made in WASM, can perform non-deterministic operations such as go to the internet and fetch some data, an image, or even like go to an LLM and essentially make a decision. And that's when the consensus kicks in, right? Because again, the problem is that you need all this network to have a mechanism to reach an agreement, a consensus, right? And if everything is kind of like probabilistic, if everything is different, if you don't have like one-to-one comparison of things, how do you make them agree on something? That's the tricky bit, right? Because we're talking about ambiguous clauses in a smart contract. How do you do that, right? That is subjective. And so the consensus was like this. There's 1,000 validators, transaction comes in, from those validators, 5 of them are selected at random, 1 is the leader, goes do something. This something is essentially an arbitrary function, can be in Python, can be in natural language, can go to the internet, anything, and it needs to make a proposal to the other guys. The other guys vote on that proposal in a majority vote. It's a simple majority vote. And if they disagree, they rotate the leader. If they agree, the transaction is accepted with a 30-minute finality window in which anyone can come in, appeal, and double the validator set. That's basically it, right? I'll kind of repeat that. What's happening is that you have 1,000 validators, out of which only 5 are selected at random at the beginning. It's a DPoS network. One of them makes a proposal, the other vote on that, and if they still disagree, you can just escalate. Escalate 7 times until you basically have the entire validator set to be able to make a decision. And why do we do this, right? Because if you're thinking about how to make decisions on chain, I'm absolutely sure that you have heard about different approaches on how to have a single AI model making the decision. Let's say proof of inference, right? There's a bunch of different approaches to this. Trying to make a process that's naturally non-deterministic, deterministic, right? How do you make that? Well, the problem is that if you have a single model, that by definition is a centralized model. It doesn't matter how you train the model. It doesn't matter how you run the model. It doesn't matter if you know exactly how it was run, because it's a single entity, a single quote mind, right? And so what we're doing is we're aggregating the minds of up to 1,000 different AIs to reach a consensus together. Different points of view basically mean that you have higher correctness, you have less bias, you have higher security. It essentially, you can trust it, right? If you guys want to read about this, it's called the Condorcet-Jury theorem, right? And it basically means that, depending on the type of question, if you get different judges that actually come together to a consensus on a majority vote, well, the correctness of the system is higher. And like this, we can actually build DeFi on top, and we can build new types of primitives, because you cannot have DeFi on something that works 99.9% of the time. You need something that works 100% of the time. And the way we're doing it is, again, if you have this thing that costs 95% of the time, if you ask 50 different validators, it will be essentially 100. Doesn't make sense to you to basically go beyond that because it's essentially 100, right? So it's a probabilistic consensus. You guys are used to having deterministic consensus. This is a probabilistic consensus. It's a dynamic consensus. What does that mean? Okay, the problem is that because all of this is probabilistic, you need them to have a way to agree. And the way that they agree is essentially because the developer can define the threshold of acceptance of a specific thing. For example, is this tweet funny? I see I don't have a lot of time. So is this tweet funny? If they agree, that's the developer said, you need to check a tweet. Is it funny? If you guys agree in a majority vote, that's good to go. This is called the equivalency principle. And this enables basically different type of primitives. Trustless decision making. It enables different types of primitives. I will show you a bunch of them, but it's essentially a judge, as I said before, right? You can have a marketing protocol where basically anybody can permissionlessly, on any blockchain, come in, put in a pool some funds, and tell the pool that if somebody creates content on your product, it can take the money. Now, the judge is essentially looking at the tweet and seeing that the content is correct. And what you see here is, it's basically doing that, right? About 20 different things. This is live today, rally.fun. You can go and visit. There's basically 125,000 people right now, in the wait list. There's thousands of decisions being made every single day. Just for the sake of time, there's also argue.fun. It's a debate prediction market. Basically, you're betting on what the AI will decide after the whole consensus goes through. It's a completely new type of prediction market, right? You just have two ends, two parties can be debating something, betting on that something, and at the end of the period, the AI decides who won. You can have a dispute resolution system. So this is an escrow. You can deploy this on Base, on whatever you want, really, because GenLayer is not trying to compete with other blockchains. It's trying to expand what they can do, right? Through layer 0, any type of interoperability protocol, you're going to be able to call GenLayer to make a trustless decision for a very, very low cost. Let's say rally costs about $1 or something like this per decision. This is holding the escrow, deciding who to release it to, and it automatically releases the escrow. And then also we have another one called merge proof. This is coming soon, which is essentially a way to manage PRs and issues in an automated fashion in a way that you have economics behind. So you have an issue, you put some bounty, anybody in the planet can come in and try to take that bounty by doing a PR, and if it gets debugged, then kind of loses money. Anyway, I'm out of time. Thank you all so much for the attention. If you want to reach out, you can find me here in the socials. Thank you so much.
Yes, thank you, and thank you for respecting the